Hey, welcome back to the series on StackIt. Last time we refactored the code a little bit, and today we actually want to go back to the min-max alpha-beta search and figure out what the issue was. Towards the end, there was a board state where I could only make basically one move, and if I make that move, the next step, the AI would find that it wins. One obvious reason for this could be that the search depth was not deep enough to find that it is winning. But yeah, we just have to look a bit deeper into that. And in order to debug that a little bit better, I want to do two things. I want to implement a, a string parser for our board, so we will be able to create boards by providing strings, because it's a bit easier than providing these two arrays, and then from there we're going to build a couple of test cases where we will assume that alpha, beta, and min-max will yield the same result, just to make sure that we are not cutting too much in alpha or beta. And we will also assert the outcome to make sure that no matter what we change on the algorithm, it doesn't suddenly find a worse outcome. So for the string representation, I already thought of something a little bit, and I thought it could look something like this. I'm not sure this is super easy to read, but it will be a bunch of numbers. The first number represents the number of boxes on that field, and the second number represents the player on that field. And then somehow we need to incorporate the the current player into this. We either just pre or append it. For now, let's just see. We make another class method from string, and then this should look something like this. So how do I do this best? To test it, let's go down first. Def, no, if from string is going to be this function. Yeah, and as I say, so in this case, we assume it was, and the board that I chose here is the board from the previous video where the AI didn't find the move. If you look at it, player 1 owns this, in this field, and player 2 owns this, in this field, and it's actually player 2's turn. So let's just append it for now. I like prepending it more. So it's player 2's turn, and in this case, player 2, no matter on which stack he puts a box, it will always collapse. And then afterwards, red is going to collapse this one, which will collapse this one in turn, and basically the whole board will be red after, and then the AI will easily find out that it's winning. Let's do something. The file has been changed since reading it. Ooh. How? This game, this board. Nope, I really want to write it. I'm pretty sure. Yes, exactly. So if we now execute board py, it will just say there's nothing to do. Invalid syntax, board string equals, so yeah, Python doesn't like this. Non-object has nothing. Okay. In case you didn't see the errors, the first error was that it doesn't like the line ending on nothing because I new lined the string, and the second one said the non-type doesn't have print function. This is because we're not returning anything from here. So we will, for now, let me see what's the current state. Yeah, it's a bit ugly, but we will basically do something similar to here. I said this a lot, that it is ugly. I should just make it better. We make a board, and then the current player will be first place. So the first character in the board string will be the player, and here we want to replace all spaces with nothing so that we can write it nicely, and also replace all new lines with nothing. Board string, and then we need to go in pairs of 2. Actually, you know what, let me see how. Let me see how this string looks like when we pass it empty separator. We cannot separate on empty. I kind of want to know, if we write it like this in Python, what do we get? So we get a new line and spaces, and then a 2 at the end. So if you split this thing on new lines, but then we force the string to be like this. Yeah, no, forget what I said. So oops. So we do this, and then we make a class. We say the first character is this, and then for this zip support. So now I want to go in steps of 2. Building functions in zip. You can just pass an iterable and if we do, how can we make sure that we skip 1? We could do it with range, but range is never nice. Board string. Board string. We go in steps of 2. And now we go from 1 to in steps of 2. 1, 3, 5. When I thought of it, it seemed to be easier. Okay, 4, 3, 1, 1. This is exactly what I wanted. Then we can do it like this, and then Board string. Yeah, before I forget it. Okay, I call this player. Type int has no length. Return length board 0. Oh, stupid. Oh, ha, funny. Okay. Now we know that this. So now we just have a long list of. How do I do that? What I'm doing now is I'm just passing a long list of numbers. It doesn't have a square shape yet. So now we assume that the board is always square. So we need to how do we make it in a nested shape? I didn't think about this at all. Okay, wait, this one passes a substring into. This one actually passes a row. Oops. And then here we need to go row, row, row. And then here we would return board and player. Because technically what this does is it passes one row and now we just want to fill it. So form and range, and we go board string from, I'm not entirely sure. We go in square root steps. So if we have a 9, if the board string, the remaining board string, yeah, this is something I should consider. This one will start going from, wow, this got way more ugly than I intended it to be. So, okay, up here we remove the first character because we know it's the current player, and after that we should be left with a square field. So if we go in steps of the square root, for example, if it's 9, then this one would be 3. Field size, let's name it, otherwise we'll never be able to figure out what happened here. We go through the whole length in steps of 0 to here, print let's do that. And square is not find I thought it's a Python built-in. Do we have NumPy already? Math. I thought it was a Python built-in. Cannot import name StackIt exception. Yeah. Whoa, what did I do? No, import math. Now this needs to be okay, 4 4. What is happening here? Ah, because nope. We need to divide it by 2 because there will be one character for the box and one character for the current player. So now we're here and we go in steps from 0 to 3, and then we need to parse row. Word string from I to I plus field size, or from 0 to 3, and then we actually get on. Wow, I need to think about this a little bit more, and then we can refactor it again. Yay! But at nighttime, I'm actually really. Oftentimes, I'm too tired to still think clearly. Anyway, so this will give us a temporary board and a temp player, and we can do I can see that. Whoa. I don't have a bracket too much. List index artifact player append row. We go from row. Let's just see what we're doing here. Plus field size times 2. Right? Not right. There's so many numbers. What's happening? Wow, in my mind this was a really easy problem. So what's gonna happen? We pass it the first 4 1 3 1 1 1. Easy, should work. And then let's see what we have here. We need to go in field size times 2 steps. Bam, this is what we wanted. Yeah, the colors are inverted, but whatever. I mean, in the original game, it was player 1 to play. Wow, this was complicated. Why is this so? Did this end up being so complicated? So field size is actually field size times 2 because we are actually reading board and player at the same time. The cool thing is now we can actually write our boards like this, which might be a bit more intuitive, maybe. Is it all? There's no built-in. Okay, let's just try this. Search. Let's just assert that the board is passed correctly, and then we can copy it to the board tests. Is this a good test? It's not. I also need to think about this. So if I want to make this a test, I somehow want to now assert that certain fields are set correctly, and I don't want to write 100 assert statements. So I wondered if I can make it somehow shorter. Yeah. Okay, let's leave this for now. And then here we can actually we can change this to use our newly built string. This, by the way, doesn't have to be this doesn't have to be all in new lines. We could make one string with just numbers, and I assume or hope it should still work from string. Bam, also moves. So 0. So maybe I just made the shittiest moves in this situation. Let me see. I can still win this. So now my goal is to make a 4 here so that he has to throw over this 4, which will kick over my 4 and make this become a 4, which doesn't fall over, and then I can throw over this 4. Oh, oops. Stupid. I'm stupid, but I want to try this again. Can I win this? So 0, 2 is not a losing move. And then 2, 1, 2, 2, 1. 2, 2. 2, 2. This is losing. Fuck me, fuck my life. How can this be? Yeah. This is complicated. Sorry for my language. Let's see, how deep is this actually searching? 8 half moves means 4 full moves. Should be easy. Let's see if we can go to 12 and what it thinks. Oh, I realized I must have forgotten some of the prints. Okay, we do 0. Oh, I'm bored. 0, 2. This might take a while. It still thinks there's no clear winning position, so I have a chance. But how? I think the only move here can be 1, 2. Let's implement something where we do then we do so if I do AI here, I just ask the AI for the opinion. And 0 and 2. Okay. 0, 2. Bam. And then what's the best move here? 1, 2. I think it's the only solution. One, 2, minus 12, 1, 2. Zero and 2. 0 and 2. What happens if I put 0, 2? Why is this not completely losing? 0, 0. This is 1. How can they have such a different worldview? So something here is wrong, and this is something we will need to debug. I mean, when I implemented the change to alpha beta, I was very sloppy and just, let's just move this code in here. I think we should do more proper testing and yeah. And okay, what did I say? 2, 1, 2, 1. Okay. Now they look close. 2, 2. Okay. Fluctuation 1, 2. Oh, this looks pretty neat. But but the computer thinks computer will win now. And I 2, 1. Right, that's the only move. So 2, 0. AI doesn't even care to win. What's happening here? I mean, AI knows that it's winning, but why is always playing 0? So, yeah, you can see there's something fishy going on. Yeah, there's only this choice. Yeah, here it's over. Is there even that much to search? Just throw the 4, man. No, he missed it. Maybe he's trying to avoid to win. No. Dragged it along. Okay, well, unfortunately we only got this parser implemented, which took way too long and it's way more complicated than I want. Maybe I'm gonna spend a little bit of time offline trying to figure out how to make it nicer and whether the format that we chose is actually nice. And then, yeah, maybe I will spend a little bit of time in the next episode rewriting this immediately, and finally then we can go back to the algorithms. I really want to figure out what's wrong with alpha beta, and yeah, from there we will do a couple of more tunings and then probably go to Monte Carlo tree search and then duke it out between those algorithms. One thing that maybe real quick would be nice to implement here is I want to be able to just perf from a position. Do we have perf in here? Yeah, we need to pass it aboard in AI. And here we try to catch an exception. Is this correct? I want to catch keyboard interrupt so that if we now write perfed, keyboard interrupt is not defined. What's the name? I'm camel casing everything now. There we go. This looks like our keyboard. Alpha beta is not callable. Also, oh wow. So actually we want perfed to run as long as possible. So let's make it depth 100. I don't know. What do we see here? So we start out with 15. Okay, this is we throw it over. Then the opponent throws over and we end up with -5. And then move score time, well, it took us 8 seconds to go to 11, 12 moves. We make a move, opponent makes a move. So every even move is interesting to us, and you can see every even move is actually where it looks pretty grim. Here we just threw over something, so we look really good, and here the opponent threw back at us. All in all, it seems 0-2 is preferred, which is kind of obvious the best move in this situation. Is there anything I can do to make this a bit less jumpy? Yeah, maybe I can Z fill the values up to a certain precision, but it's fine, right? One plan I have is if we refactor the board a little bit to use NumPy underneath, I think it will be much faster to simulate all those positions. So I guess we could maybe half the time it takes to search to a given depth. And another thing is if we implement principal variation search. This might already help alpha beta a lot. What that does is when we go down to depth 4, for example, so there will be a iterative deepening approach, which means we when we start searching for the best move, we search to depth 1, then we search to depth 2, then we search to depth 3, then we search to depth 4, similar to what Perf is doing. And this will speed up the search by a lot because we will know which was the best move in the previous depth, and this is the one that we're gonna play in the next depth. And by doing this, we will actually force a lot of alpha beta cutoffs to happen, because if we assume that this is really the best line, and if it was also the best line, we would eventually cut off large chunks of the tree by just saying we already found something much better. Yeah, so, and then one more thing I think that might help a lot would be hash tables, because in the hash tables we can probably encode something like symmetry, and then we would store which position we already looked at while searching the game tree, and then if we find a similar position somewhere else in the tree, we don't need to do the full search again, or we would know what is the best move in this situation, and we could look do that move first, continuing, resulting in more cutoffs. So hash tables will be a big one. And then I think my personal hope would be that 14 would actually be a depth in this position that is easy to reach. We don't even have to wait very long, maybe a couple of seconds, but not 87. Yeah, interesting. One interesting thing to note is 0-0 is best play because he will throw over this 4, and then we play 1-2. This is always the best play because then we kind of gain something in the middle. Yeah, I think principal variation search is gonna help. You can see in all of these tries, he had to rediscover the line from scratch, meaning try every possible move according to the ordering that we start, which is top left to bottom right. And yeah, in this case it might not necessarily help that much because 0-0 is always the first move that we would try. Yeah, but just imagine if the board grows. We're already kind of struggling on a small board like this. But let's see. I'm curious. So I was rambling a lot now. This episode is becoming a bit long. Thanks for watching, and see you in the next episode.